Hey, welcome to this episode where we talk about the last item in the recipe for carefree dependency management in Java projects. If you follow the first 5 items of the recipe in your Java project, you have a good structure where you know what you need to touch when you work on anything related to dependency management. You have dedicated places to add new third-party libraries and places to change the dependencies between your own modules or your modules and third-party libraries. While you work on implementation details in your code, you might not have to touch these places at all. If you use one of the libraries intensively, you may discover bugs or request new features. And if these are provided, you actively want to update the library to a new version. We talked about that when we looked at version management, which is item 2 of the recipe. Updating versions of third-party libraries only when you need it because you need a certain feature or bug fix is certainly one approach, but there are a number of reasons why you should update third-party library versions regularly, not only when you need it motivated by your code changes. The most prominent reason is probably security. Many libraries contain unknown vulnerabilities. Once these are discovered, they become widely known as the open source libraries are used in many places. To avoid having your software compromised by a vulnerability in a library you use, you should certainly update the corresponding version when a critical vulnerability is discovered. However, there is value in updating as many third-party library versions as possible, ideally all of them, regularly. This is because, as discussed in the initial video of this series, many third-party modules in the Java ecosystem depend on each other. So you have cross-dependencies between different modules you use. And updating one version might automatically lead to updating another one. And if the updates break anything in your software, it becomes harder to identify the cause if you have to do many large updates at once. Therefore, keeping versions updated regularly helps to avoid stressful situations when a new vulnerability needs to be addressed quickly. Therefore, this 6th item of the recipe, which is about automatic updates, is much about a process you implement in your development team to do such regular updates. What this means concretely is something you need to decide for your setup. Regular updates can mean update as soon as a version is released, or inspecting all dependency once a week or once a month for all available updates. Depending on how you organize this can be more or less a manual process. But there are tools available that can help you, in particular if you have trouble establishing such a process without tool support. While the dependency management tools Gradle and Maven have features that can help you to determine which new versions are available, there are other tools that provide additional automation, as this is a process that is not triggered as part of your build, but by some external event, like a vulnerability is discovered or a new version of an open source module is released. In this video, I would like to give an overview about the available tools. How to configure them in detail depends on the process you like to implement. Configuring one of the tools is less involved than the items we talked about previously, as they do not interact with the different dependency resolution features of the build tools. The most widely used tools in this area at the moment are Renovate and Dependabot. The major feature they provide that Gradle or Maven don't offer is integration with code hosting platforms such as GitHub, GitLab or Bitbucket. Both tools can be configured to automatically update the file used for version management once a new release of an open source module you use becomes available. The typical setup is that the tool creates a pull request or merge request so that you can review the change and, if it is good, integrate it with a single button click. And the amount of automation can be varied in many dimensions. You can, for example, configure how often the tools check for updates, like daily or weekly, if all updates are done in single pull requests or if multiple updates are combined in one pull request. And you can even go as far to tell the tool to automatically integrate an update. If you have sufficient test coverage into which you trust, this reduces the amount of manual work needed for updates to the minimum, as you only need to take a closer look when an update really breaks something. For detailed configuration instructions, please refer to the documentation of the corresponding tool. I would just give a short overview on how to get started with these two tools. In general, Renovate offers more configuration options and supports more code hosting platforms. If you run a hosted GitHub or Bitbucket platform or develop on the public GitHub.com platform, you can activate Renovate through a bot application they provide. To get started, this is as simple as activating the app and then adding a very small configuration file, which the app can even do automatically for you in some cases. Dependabot is part of GitHub and only works with the GitHub platform. But here it is enough to add a small configuration file for it to get active. Note that in this setup, both tools are commercial tools. In many cases, you might not have any additional costs using them, but still part of the tooling is closed source. Renovate, however, also offers you a solution that you fully control yourself. You can run the Renovate CLI application on one of your own servers, and then it integrates with even more platforms. Once any of these is active, you will get pull requests for new releases of the third-party modules you use. In the JavaRCAde example, we have a few update PRs from Renovate open right now. One of them is the update for the Commons.io module that we used as an example before. Renovate can not only update the versions of the modules you're using, but also the versions of additional Gradle or Maven plugins, or even Gradle or Maven itself. If you have a code hosting setup that supports one of these tools, it may be worth looking into how it can improve your regular third-party open source module version update process. As it is related, I want to mention that there are a number of commercial services and tools that also integrate with the code hosting platforms that scan your dependency setup for possible vulnerabilities. One of these might be a good addition to get informed as soon as possible as a vulnerability is discovered to prioritize the dependency updates. However, if you manage to keep everything up to date regularly, you will run into very few of such incidents at all. Now, I said earlier that you could also do the update process without using one of the tools. And maybe if you don't use one of the mentioned platforms, these tools are not available. If you don't use too many third-party modules and framework, you may do updates manually regularly. To at least have a certain amount of tool support here, you could also use features of Gradle or Maven's dependency management. Maven offers a display dependency updates goal out of the box that you can run independent of the build. If you execute it, it will check the repositories you defined, Maven Central in the case of our example, for new versions of the modules you are using. Then you can use this information to manually do the updates. You can also use this to build something that goes into the direction of Renovate or Dependabot in your CI pipeline. You could set up a pipeline that runs in a fixed interval, calls the display dependency updates goal, and then uses the output of the goal to do further automation, such as notifying you about new updates, or maybe even creating a PR automatically similar to what the other tools do. In Gradle, you don't have a similar task out of the box, but based on Gradle's flexible dependency management, you can write your own tasks that do something similar. I'll link to an example that shows how to do that in the description. The advantage of this is that you can do more automation inside Gradle directly, and the task can provide an output that is good to process by further automation afterwards in your CI pipeline, like a text file or a JSON file that contains all the relevant information to submit an informative notification or create an update PR. The advantage here could even be that you have more information about which versions are involved in the dependency resolution process. For example, you would know if the version that is used in the end is the one that was declared. Renovate or Dependabot don't have any insights about the dependency resolution process inside Gradle. They pass the file with the version declarations themselves and know only the information that is input to the resolution process, but not the results. This concludes the series of videos on the items in the recipe for carefree dependency management in Java projects. In the next video, I'll provide a short summary to wrap up the topic. See you then.